Welcome to Introduction to Computer Science, Information Systems. This is Lecture C. The component, Introduction to Computer Science, provides a basic overview of computer architecture, data organization, representation and structure, structure of programming languages, networking, and data communication. It also includes some of the basic terminology of computing. The learning objectives for this unit, Information Systems, are to define an information system, how one is used, and list examples. Describe the components of an information system. Describe the process for developing an information system. Describe specialized information systems. And explain how information systems are used in healthcare. This lecture focuses on specialized information systems and use of information systems in healthcare. There are many specialized information systems employed by business, science, and medical institutions. Knowledge management systems attempt to generate and report knowledge in addition to data and information. An example of a knowledge management system would be a system collecting medical journal articles. Expert systems use artificial intelligence and knowledge to provide solutions to problems. Virtual reality systems perform simulations where users are immersed in the simulated or virtual environment. Virtual systems are widely used in healthcare for training, in surgery, and for telemedicine. Expert systems use user-provided rules and data to support decision-making. They consist of three parts: a knowledge base, an inference engine, and an interface. The knowledge base is the set of rules that the expert system knows. The inference engine uses these rules to produce reasoning based on them. Often, the system needs additional input from the user during the reasoning process. The user interface communicates information from and to the user. Expert systems are used in medicine for diagnoses, prescribing medication, and for decision-making. In order for computers to act intelligently, they must have access to extensive and easily retrieved knowledge. There are numerous applications of expert systems in healthcare, where they are also known as clinical decision support, or CDS. They can provide support for medical decisions, such as diagnosis, treatment, and medication. When considering prescribing a medication, the system checks for allergies, drug interactions, and dosage recommendations. A unique expert system is IBM Watson, IBM's intelligent computer system. It is being adapted to be an expert decision support system in healthcare. It analyzes massive amounts of up-to-date information, such as journal articles, clinical studies, similar cases, and laboratory findings to help medical personnel make decisions. There are many different types of information systems used in healthcare settings today. A large hospital, for example, may have dozens of them. Some are very small and specific, such as those that support medical equipment like electroencephalograms or EEGs. Others are large and broad, such as the business financial systems. Together, they support and connect the different business operations, healthcare practices, and settings. The systems must be well connected within the institution as well as externally in order to communicate information outside the institution. Finally, because patient data is so sensitive, the information systems must be secure and private. Information systems in healthcare have a variety of functions and goals. First of all, information systems such as human resources, financial operations, and inventory maintenance support the business operations of a hospital or healthcare institution. Second, information systems support the operations related to healthcare, such as scheduling, billing, reporting for accreditation, and physician ordering. They also provide clinical documentation through the use of electronic health records. Communication is an important goal of healthcare systems, and it encompasses different types of communication between providers, between patients and providers, and between institutions for communicating patient data and for supporting telemedicine. Healthcare systems improve patient care and safety in a variety of ways. They provide services such as alerts and reminders for orders, pharmacy allergy and drug interaction checks, care management coordination, and monitoring systems in the operation room, to name a few. Finally, information systems aim to provide security within the healthcare setting. This includes computer security and security of patient data, but it also includes things like controlling access to rooms or floors of a hospital and patient tracking. It is common for one hospital to support dozens of different information systems. All or many of them may be bundled together by a single vendor, or each of the systems may be from a different company. This slide shows a list of some of the information systems that can be found in a hospital. The first is a hospital's business information systems. This includes the information systems needed to keep the hospital business running, such as the financial and human resource information systems. Registration systems coordinate all inpatient and outpatient activities in the hospital. Registration systems send messages to other systems every time the patient signs in for an appointment, is admitted to the hospital, and when there are changes to a patient's demographic or billing data. These are called Admit Discharge Transfer, or ADT messages. Scheduling systems manage patient appointments and are crucial for the functioning of different departments. The Master Patient Index, or MPI, assures that patients are identified across all systems in the hospital and different units of hospital systems. Laboratory Information Systems, or LIS, help manage the data and processes within scientific laboratory settings. For example, hospitals have labs that can analyze patient blood draws or perform gene sequencing for research. Laboratory information systems are used for managing data within the lab and for processing orders and communicating results to and from other systems. A pathology reporting system is one type of LIS. Imaging information systems manage the large amounts of image data collected electronically, such as X-rays and scans from magnetic resonance imaging systems, or MRIs, and from computerized axial tomography, or CAT scans. They must support PACS, the Picture Archiving and Communication System, which is used to store and access electronic images. Pharmacy information systems, or PIS, can be complex and often involve robots. Pharmacies receive orders, check orders for problems with drug-to-drug interactions, make sure that the patient does not have allergies, mix IV fluid, often robotically, package and dispense to wards, manage billing and supplies, as well as manage communication with providers. Biomedical equipment such as electrocardiogram or EKG machines have their own information systems for managing and interpreting the data collected during monitoring. In addition, this equipment is used for monitoring patients' heart rate, blood pressure, and ventilator settings, to name a few. Clinical decision support systems are often integrated with the electronic health record, or EHR. Alerts and reminders are common decision support tools and are often used for preventive health services. They also have many other uses, like suggesting ancillary orders, for example, or lab tests that should be performed when certain drugs are given. Drug-to-drug interaction and allergy checking are decision support tools that may be used by pharmacies or in the EHR when ordering medications. Smart order sets help providers make the right decisions when ordering labs and medications. Finally, EHRs manage the data related to a particular patient. They are used to both collect data and to display data that is collected in other information systems, such as labs, EKGs, etc. Connecting between all these systems is crucial for successful operations. Communication standards were developed, such as the HL7 standards for medical data and the Digital Imaging and Communications in Medicine, or DICOM standards for medical images. There must also be standards for terminology so that it is consistent across systems. Next, there must be a high-bandwidth network connecting the systems, particularly those that are sending and receiving large amounts of data, such as images. Finally, different systems must communicate with each other using an interface. If each system has a separate interface to every other system, there would be many different interfaces within one enterprise. Instead, systems can be connected using an interface engine, which handles interfaces between the systems. Since healthcare data is highly sensitive, the connections must be secure. They must also be reliable, since healthcare systems must be up and running while the institution is open, and hospitals are open 24 hours a day, 7 days a week, and connections are crucial to all business and healthcare operations. This includes patient records, schedules, medications, as well as bioequipment and life support systems that keep patients alive. Finally, the connections must be efficient and run as fast as possible. This slide shows a simplified diagram of the information systems at a hospital. In the upper left corner, there are the central healthcare systems, the EHR, the Master Patient Index, or MPI, the scheduling system, the registration system, and the billing system. These typically connect to one central server. On the right are the administrative systems that support the hospital. These include everything from human resources, or HR systems, to the executive information systems, or EIS, to logistics systems, to accounting and reimbursement systems. Along the bottom are the many ancillary systems. These include laboratory information systems, systems used for monitoring and testing cardiac conditions, systems used in the intensive care unit or ICU, and in operating rooms or ORs, and the PACS systems used for imaging. There are many other systems that could be included in this category. Because there are so many systems that need to interface with other ancillary systems and the other healthcare and administration systems, the ancillary systems commonly connect to an interface engine, which in turn connects to all the other systems. Finally, all the groups of systems also connect to the Internet for external operations, such as communicating medical data to and from other institutions, and connecting to outside systems for reimbursement. One of the smaller pieces of an entire hospital information system is the imaging information system. At the center of the imaging information system diagram is the Picture Archiving and Communication System, or PACS. When an image is needed, the Computerized Physician Order Entry System, or CPOE, within an EHR places an order for the image to the scheduling and registration systems. These systems also interact with the Imaging Modality System and the PACS for coordination of the appointment information. Then, the PACS takes input images from different imaging modalities, stores them, and communicates them to different entities. For example, there are PACS viewers, like the review station in the diagram on this slide, that will display the electronic images. These images can be archived and stored, transferred to media such as CDs and DVDs, printed, and communicated back to the EHR in the form of a report or communicated to external specialists for review. Another part of a hospital information system is the Pharmacy Information System, or PIS. The Pharmacy Information System is responsible for coordinating all the activities related to the pharmacy operations, including the management of prescriptions, maintenance of the inventory of medications, and the generation of reports. The pharmacy usually has a Clinical Decision Support System, or CDS, that automatically checks for allergies and drug-to-drug interactions. In addition, the pharmacy may have electronic dispensing systems facilitated by robots. The Pharmacy Information System communicates with the EHR and processes and manages orders received from the CPOE. The PIS also communicates with systems within the hospital related to patient care, such as the Electronic Medication Administration Record, or EMAR, which keeps track of administered medications, electronically controlled infusion pumps, and dispensing cabinets. Another part of the information systems at a hospital is the data warehouse system. Data warehouse systems are a collection of data from across an institution. Queries and reports can be generated from the warehouse that can help discover knowledge related to the system. It is important to note that the queries and reports created from the data warehouse cannot be generated from individual systems. The data repository of a hospital warehouse system gathers data from all the other systems in the hospital, healthcare systems, administration systems, and ancillary systems. After processing the data, which may include summarizing, reorganizing for easier queries, identifying, and correcting erroneous information, the data is transferred to the data warehouse, where queries and reports can be generated. Queries can be for operational purposes, such as, what are our revenues and expenses from the new cardiac laboratory? Or, what is the hospital-acquired infection rate for each unit compared with their staffing level? Or queries can be for research, particularly for identifying patients who are eligible for research, such as, what and how many patients have a diagnosis of diabetes with at least one hemoglobin A1C of greater than 8 as an outpatient in the last year, and have been hospitalized more than once in the past year. Information systems in clinics perform many of the same tasks that hospital systems do, but on a smaller scale. In a clinic, these systems may be separate or they may be combined into one system. Similar to a hospital setting, in a clinic there are systems that register patients, schedule appointments, and manage billing. There is an EHR for collecting, managing, and displaying patient data. Clinic information systems need to communicate with systems outside the clinic, such as pharmacies, labs, and imaging services. This slide shows a diagram of a clinic information system operating independently, in other words, not being part of a hospital. Note that the light-colored boxes represent parts of the clinic system. The dark boxes are external systems. At the core of the clinic system is the EHR, billing, and registration and scheduling systems. These can be separate systems or integrated together. This central system then connects to external systems such as outside labs, outside imaging, and outside pharmacies. While it is common for EHRs to be able to order medication, labs, or images from outside systems, it is less common for all results to be communicated back electronically, particularly images. Instead, the outside labs or imaging will fax or mail results and reports to the clinic, where they can be scanned and imported to the EHR. They may also be printed and included in the patient's paper chart, which often still exist in clinics, even those with an EHR. It is not surprising that clinic systems are far less complex than a system at a hospital. And while there may be electronic connections to outside systems, oftentimes clinics still rely on fax or mail for receiving reports from outside systems. This concludes Lecture C of Information Systems. In summary, some types of specialized information systems used in healthcare include knowledge management systems, which attempt to generate and report knowledge in addition to data and information, expert systems, which use artificial intelligence and build on knowledge to provide decision-making assistance, and virtual reality systems, which enable training in simulated environments. Healthcare settings use information systems for numerous purposes, including managing billing, financial data, laboratory data, and patient records. This also concludes the unit on information systems. In summary, information systems combine technology, people, and processes to produce and use information. Institutions rely on information systems for managing data and processes, providing knowledge, and for supporting communication and collaboration. New information systems are developed using a process that includes planning, analysis, design, implementation, and support and security. Information systems are used extensively in healthcare.